Thank you for joining us today for the SD-RAN version 1.5 Techinar. I'd now like to introduce our presenters, Woo-Jeong Kim and Hyunmin Yu. Gentlemen, please take it away.
Thank you very much, Dennis. Hi, this is Woo-Jeong. I'm working for Pure Storage, and I'm also working for SD-RAN as well as an engineering lead in A30ST. Today I'm going to talk about the SD-RAN release 1.5, and here I would like to also introduce our new engineering team as well. And also, of course, this will cover what was changed for the SD-RAN 1.5 release from the 1.4. And then at the end of this presentation, I would like to show what will come later for the 1.6 release and its timeline. Yeah, so this is the overview of the SD-RAN release 1.5. So there are four bullets, four major points. The first one, the biggest one, is the updating the X application to replace the ONF community service model with ONRC service model. So basically, I will cover it later a little bit more, but previously for ONOS PCI, MLB, and MHO X applications, those have used ONF community service models. So ONOS PCI and MLB have used the RC pre-service model. And also ONOS MHO have used ONF MHO service model. But from 1.5, they are using ORAN RC official service model. And second part is SD-RAN Rig is now working with OAI 5G RAN stack. Basically, well, it's not OAI latest code, but we forked OAI source code and then added some of our own E2 agent there. And by using that, OAI 5G RAN stack is working with SD-RAN Rig with KPM service model. So that is the second part. And third one is, well, previously SD-RAN 1.5 has its own CI pipeline based on Jenkins, but now we are trying to change. Well, in this release, we tried to change that Jenkins into a GitHub action. And the last part is we also integrate our SD-RAN into the Ether ONNET as a new blueprint. So those are the major points. So let's go one by one. So let's revisit the 1.4 key components. So in 1.4, basically we introduced almost A1T components there. And by using that, we introduced Remedo traffic steering X application. And by using Python SDK, we also introduced the Intel Connection Management X application. And we also supported the Circom 5G G-Node B. So by using KPI-mon, we can get some monitoring information from Circom G-Node B. This is the commercial device. So that was the major point in 1.4. And in 1.5, those are the new changes. So new components, two new components are introduced here. So first one is, like I mentioned, ONF OAI 5G RAN stack. And second part is Ether ONNET SD-RAN blueprint. So not only SD-RAN in a box, but also Ether ONNET can deploy SD-RAN everything in a Kubernetes cluster. So that is the new component. And the updated things, like I mentioned previously, PCI, MLB, and MHO X applications have worked with ONF RC pre-service model or MHO service model, but now they are updated to use ORAN RC service model. So it's working fine. I will demonstrate it a little bit today. And here in this Techinar, we would like to announce that SD-RAN in a box will be deprecated in about next one or two releases. And that means, well, to deploy SD-RAN in a box in next one or two, after one or two releases, Ether ONNET is the only tool to deploy SD-RAN components. So while during this one or two releases, we are really focusing on integrating the SD-RAN in a box, migrating SD-RAN in a box features into the Ether ONNET. So that is one of our major goals for next one or two releases. and after that we will deprecate it. Of course, well, in the next 1 or 2 releases, of course, well, SDRAM in the box will be still alive, but we will not add the new features in SDRAM in the box, but we'll add new features into the Ethernet and then migrate some existing features from SDRAM in a box into the Ethernet one by one. So that is one announcement for SDRAM in a box. And the last one is we actually deprecated Python related components. So in the left side here, Python-based SDK and some X applications like Intel CMX app, Facebook KPI X app, and Facebook AirHop X applications. Those are deprecated. Well, let's say it's the code and Python SDK are still within Ono's project workspace, but no one is updating it after every release. So we are saying it's deprecated, and also there is no new use case with Python-based X application. So we decided deprecating it, but and also, well, SDRAM engineering team has no resource to control this Python-based SDK at this time. So we discontinued this project and components. But if there is a new use case coming in next releases, and if we have more resources for it, then we will resume it, or we will implement those Python-based SDK and X applications. So that is the key changes in 1.5. So let's go through one by one. Before we go over, I would like to also show you the use cases and their versions. So the first, this table shows all the use cases that SDRAM 1.5 is currently supporting. There is no new use cases. So KPI monitoring, PCI conflict resolution, mobility load balancing, MHO, RAN slicing management, and traffic steering. Those are the existing use cases. And they are working with the Ono's KPI Mon, PCI, MLB, MHO, RSM, and Remedo traffic steering X applications, respectively. But the only change is the service model versions and E2AP versions. So KPI monitoring version, KPI monitoring X application uses E2SM KPI version 2.0.03. And PCI, mobility load balancing, and mobile handover, those are using E2SM, ORAN E2SM RC 1.2.03. And RAN slicing management, it's still using ONF RAN slicing management service model. And policy-driven traffic steering, which is the Remedo traffic steering X application, still uses ONF MHO service model version 2.0. And those X application can work either OAI, SDRAM OAI 5G RAN, 4G 5G RAN stack, or RAN simulator. But KPI Mon and RAN slicing management X application, those two X applications can work with OAI RAN stack, and RAN sim supports everything. So KPI monitoring, by using Ono's KPI Mon, we can monitor some cell information, even though the cell type is OAI RAN stack. So it supports 4G, 5G both, and by using E2AP version 2.0. And also for RAN slicing, we didn't change anything, so we still supports it, and by using OAI 4G RAN stack, not 5G, but 4G RAN stack with E2AP version 2.0, we can manage the RAN slicing there. And PCI conflict, MLB, MHO, and policy-driven traffic steering, those are not working with OAI RAN stack at this time. But RAN simulator, by using E2AP 2.0 version, KPI Mon, PCI, MLB, MHO, RSM, Remedo TS, every X applications and use cases can work with this. So if we would like to, RAN simulator is, literally it's a simulator. So it's a very much starting point to implement your new use cases. And of course, if we, I will cover it later in the future as a future work. But if we would like to introduce the new use case, then RAN simulator should be the first starting point. And then, if possible, we would like to integrate those features into the OAI RAN stack so that we can test everything with the real hardware. Of course, it's SDR-based hardware, but yeah, real hardware. So that is an overview of the SDR 1.5. So yeah, let's jump into the ORAN's RC service model integration. So the major goal for this is to replace the ONF community service model with the official ORAN service model. So this is the effort to expand our SD-RAN support coverage. So for example, if the kind of new commercial hardware wants to use SD-RAN brick, but it doesn't support RC service mode, SD-RAN bricks, for example, PCI use case. But if it doesn't support the ORAN official service model or ONF service model, then the commercial software doesn't know. Well, it is really hard to communicate with RC service model because if that PCI X application only supports our own service model, right? So, but ORAN service model is official one and it is very much standard things, official standard things. So if we support it, we can say we are trying to expand our support coverage. So that is why we try to replace the ONF community service model with the official ORAN service model. That is the goal. And like I mentioned, the scope is those 3X applications. It was PCI, MLB, and MHU. So PCI have used ONF RC pre-service model, and MLB also have used ONF RC pre-service model, but they changed it to ORAN RC service model now. And almost MHU, mobile handover, that is previously that have used ONF MHU service model, but now it's using ORAN RC service model, the official service model now. So let's go one by one for each X application, I mean. So I think you guys already know about the PCI X application, but I will briefly introduce this X application again. So basically, PCI is the physical cell ID, and that physical cell ID should be unique within the neighbor cell list, right? But if it's not unique, then it's in trouble, right? So this PCI X application and PCI use case tries to detect the PCI conflict situation and then try to resolve that situation. So this is how it's working. So once Gnode B or eNode B is online, then let's say that those are RAN node. Once RAN node is online, then RAN node sends its neighbor cell list to the rig with the PCI information. And that means the almost near real-time rig can draw the global network view, right? And by using that global network view, rig can detect the PCI conflict situation. So once it is detected, the almost near real-time rig can resolve that situation by sending the control message. So that is how PCI X application is working. So previously that was working with ONF RC service model, but it is changed to official ORAN RC service model. So this is the just brief whole flow. So let's assume that there are 3 Gnode Bs, and as you can see, Gnode B1 and Gnode B3 have same PCI like 25, and Gnode B2 has 26. Which is unique. Here by using this information, we can see Gnode B1 and Gnode B3. If they are neighbor, then PCI conflict will happen, right? So the first thing is, but Gnode B1, Gnode B2, Gnode B3, those Gnode Bs send a subscription message, and after some packet, the message exchanges, Gnode B1, Gnode B2, Gnode B3 subscribes, have a subscription, E2 subscription channels to the rig. And then after that, let's assume that Gnode B1 and GNode B2, well, between them, there is an access setup procedure happens. Then, once it happened, that means that GNode B1 and GNode B2, now they are neighbor, right? If that happens, then GNode B1, GNode B2, those are sending the indication message to RIG that GNode B1's let's focus on the GNode B1. If GNode B, in the indication message from the GNode B1, it has its neighbor cell, in this case GNode B2, and its PCI information. Then RIG will know GNode B1's PCI as well as GNode B1's neighbor, that is GNode B2 now. Likewise, GNode B2 sends the RIG indication message to the RIG, then RIG will know GNode B2's neighbor is GNode B1 and GNode B2's PCI is 26. And next time, access setup procedure happens again between GNode B2 and 3. In this case, those GNode Bs send out the RIG indication message to the RIG so that RIG can understand GNode B2's neighbor is GNode B3 and GNode B3's neighbor is GNode B2, right? So that is the current procedure. And after that, access setup procedure happens again between GNode B1 and 3. Then they will send the RIG indication message to the RIG. And here, RIG can identify GNode B1's neighbor is GNode B3, and they have the same PCI. So this PCI conflict is detected after that the indication message comes in. So if it happens, then RIG should send the control message to one of GNode B1 or GNode B3 to change the PCI. So for example, if RIG sends the control message to the GNode B3 with the PCI, different PCI number, let's say 27, for example. In that case, PCI resolution can be PCI conflict can be resolved, right? So then now we have one more open question: which GNode B should be changed, right? So simply, well, in our X application, simply we just check how many UEs are connected to each GNode B. Well, it's assuming that RIG already has the KPI Monex application running there, and KPI Monex application monitors how many UEs are connected to each GNode B. So that was the assumption. And if, for example, GNode B3 has 5 UEs, but GNode B1 has 7 UEs, in that case, RIG will send the control message to change the PCI to GNode B3 so that we can reduce the kind of the impact, like, because, well, it only has 5, which is lower than GNode B1. So only 5 UEs will be impacted, and it is better than sending the control message to GNode B. So that is the reason why we check the number of service UEs for each GNode B and then send out the control message. But this is the optional one. So if KPI mode is not working, then that means this how many UEs a PCI-X application doesn't know how many UEs are connected to each GNode B, right? In that case, if KPI mode is not working, then, well, PCI-X application just send a control message to one of the GNode B randomly. So that is how the PCI-X application working. And this RIG subscription and the indication message and control message, all of those things are working with the official RC service model. And next one is the MLB-X application, mobility load balancing application. So the major assumption for mobility load balancing application is if one of the GNode B is overloaded, but its neighbor cells are not overloaded, let's say the load for those neighbor cells are under the threshold, then this X application tries to change the load balance, handover region, so that the overloaded GNode B's UE is handed it over to the neighbor cells. So that is the major operation for the mobility load balancing X application. And well, the mobility load balancing X application has to run along with the KPI Monex application and PCIX application. So KPI Monex application has monitors a kind of the number of UEs per cell, and MLBX application uses the number of UEs per cell as a load for each cell. So KPI Mon should monitor how many UEs are connected there. So that is the first mandatory point. And second one is PCIX application is also needed because PCIX, like I mentioned earlier, with the PCIX application, each cell will send the neighbor cell list, right? So by using PCIX application, basically almost near real-time rig can get some global network view. So which cell is this cell's neighbor cells or something like that. That kind of global view, we can get it by using PCIX application. So to get the load and to get the neighbor cell list, the MLBX application has to work along with KPI-Monex application and PCIX application. So by using that load information as well as the the neighbor cell list information, MLBX application simply detects which cell is overloaded and which cell is not overloaded, or even under the target threshold. So it's working periodically. I mean, the MLBX application checks this kind of load balancing logic periodically. We can, of course, kind of configure it, but normally by default, it's working every 10 seconds or 1 minute. And at every period, MLBX application checks which cell is overloaded, and it can shrink their handover region or expand the handover region. And if it's possible, then PCIX application set up the policy to the target GNODEs. So this is how it's working, and this is the brief code flow. So if there is a near real-time rig running here, and GNODE B is connected to the near real-time rig, and let's say UE is connected to the GNODE B. So first, need to set up requests setup messages are exchanged so that GNODE B and near real-time rig has a channel. And of course, UE sends the RRC connection reconfiguration message or measurement report periodically. If it is connected, then well, this message comes in. Or if handover requires, then UE will send the measurement report. I mean, if A3 event, for example, happens, then UE will send out the measurement report to the GNODE B. So that is the major assumption. And then, like I mentioned, in this situation, MLBX application can get the monitoring result to check the load from the KPI mode. Basically, it has RNIP. Well, because KPI mode always store that monitoring information to RNIP. So near real-time MLBX application get the load information via RNIP. And also the cell information, neighbor cell information is also stored in RNIP as well through the PCIX application. So all the information like load information and neighbor information, they are stored in RNIP. So by using RNIP, MLB can get those essential information. So once it's received, then it's like I mentioned, it's working periodically. So in T1 time, if the X application think the OCN value should be changed by reducing or expanding the handover region, then the X application sends the policy, set up the policy to this GNODE B. And next time in T2, if the OCN should be changed again to change the handover region, then that X application set up the policy to the GNODE B again. And let's assume that if OCN T2 is configured here, but UE wants to, well, by using this one, well, sometimes UE should be kicked out to the other cell, right? In that case, well, UE will send a measurement report to the GNODE B. And by using the new OCN value, GNODE B can decide if this UE should be kicked out or this UE should be here still from the load balancing perspective. So this is how MLBX application is working. And those policy is something defined inside the ORAN RC service model as well. So this is about the MLDX application. And next one is the MHO, mobile handover X application. So it's a bit more simple. Forget about the MLDX application. In MHOX application, we don't touch any kind of handover parameter. It's just working like if A3 event happens from the UE and between the UE and GNodeB side, then GNodeB hold off that handover event and then report it to the X application with the indication message. And if X application think it's available or if it's valid, then MHOX application accept or deny that handover by sending the control message. So that is how MHOX application is working. And as of now, this MHOX application doesn't have any kind of intelligent logic. If that indication message comes in with the insert mode, then MHO just approve it. But we can expand it like by we can expand it as a kind of admission control X application or something. But as of now, it's just kind of the very naive X application. Just approve all the MHO handover requests, and then once the control message comes into the GNodeB side, then like I mentioned, handover procedure was hold off. But once control message comes in, then this procedure resumed. So that is how MHOX application is working. So this is the brief code flow. Basically, let's assume we have three components, GNodeB, UE, and RIG here. So first, we need to make a E2 subscription here, but here we need to set the insert mode here. So, and once UE send out the A3 measurement report for handover, again, well, it doesn't change any kind of handover region or something, but just leave all the handover logic as is in GNodeB and UE at this time. And once A3 measurement report comes in, then GNodeB report that A3 measurement report received to the RIG. And of course, GNodeB, and once it's received, then GNodeB should start the handover procedure. But in this use case, GNodeB hold off that procedure at some moment, and then near real time, and then wait the control message from the near real time RIG. So once near real time RIG sends the control message to the GNodeB, then it can resume the handover procedure again. And then once it's done, then UE finally can be handed over to the other server into this cell. So this is the MHOX application procedure. So before we go to the next topic, I would like to show each X application working. So the first one, let me make it bigger. So this is first one is the PCI X application. So I already deployed SDRAN with this SDRAN in a box for the PCI use case. So if we go to ONOS CLI, and first we need to check what kind of service model we are using for this use case, right? So if we go to E2T list subscription, and as you can see, there are only two service models. First one is ORAN RC service model. The other one is ORAN KPM service model. Previously, well, there was no ORAN RC service model here, but ONF RC pre-service model we can see here, but it was changed to the RC service model. And also we can see the PCI application result. So here PCI get resolved first cells. So there are 1, 2, 3, 4, 5, 6 cells here, and those are the PCI. And as you can see, all of those PCIs are unique. And well, also assuming that we can assume that those cells are all neighbor cells for each other. So here PCIs are all unique. And why it is unique? Because this PCI X application resolved one of the PCI conflict. So here, this is the event log, event history. So this cell ID previously it has 480 PCI value, but it was changed to 7. This guy also had 480 to 293, and this guy had 276 to 28. So I think there are some race condition because the PCI-X application tries to change the cells PCI for both cells because previously they had 480 the same PCI, but PCI-X application tried to change their PCI values to the different one. Probably there should be some race condition. We will fix it, but ideally at the end of the day, well, the PCI-X application resolved all the PCI conflict at this time. So this is how PCI is working. And next one is MLB. So SSH. So go to another cluster that I prepared. And as you can see, sorry. As you can see, the ONOS SD-WAN projects are deployed here. And this is the MLB. So like I mentioned, MLB requires both PCI-X application as well as the KPI-1X application. So I also deployed KPI-1X application and PCI-X application here. So if I go to CLI, and then let's check the E2T subscription. And as you can see here, we can see KPM service model as well as RC service model, right? There is no RC pre or an RC pre, ONF RC pre or MHO service models here. We completely replaced them with the ORAN RC service model. So here we can also check get cells. Oh, yeah, cell. Oh, sorry, not MHO, MLB. List parameters. So basically, by using this CLI, we can configure the MLB parameters, like I mentioned, it's working periodically, so we can change intervals, or we can change every time we need to increase or decrease the OCN values, but every step, how many OCN values we would like to increase. So that kind of things we can define here. And basically, MLB application is working based on the threshold manner. So if exceeding this threshold, then that means that that cell is overloaded. Overloaded threshold, exceeding the overall threshold, that cell is overloaded. Or if the cell has the load under the target threshold, that means that is underloaded cells. So we can configure it on this command line, and we can also check the current OCN values as well per cell. So currently everything is every cell has OCN value 0 because we can say all of the cells are under the target threshold or in between overload threshold and target threshold. So which means that everything is looking good. But if one of the cell is overloaded, and their neighbor cell is not overloaded, then the load balancing will happen by changing the OCN value. So that is how MLB is working. And MHO, I also created another cluster. And here, CTR get pod A. So here you can see MHX application is running. So if we go to CLI and check E2T, as you can see, there are also KPM and RC service model only. There is no ONF MHO service model anymore. And here, MHO, we can check cells. I think 1 second. So, oops. So currently this cell, 54001 has 1 UEs. And the scenario is quite simple. There are 2 cells running, and one UEs are moving around this 2 cells. So far here, until this time, the single UE is connected to this cell, but now it is changed to the other cell by due to the handover situation, right? So this is captured in MHX application, and by once measurement report comes in, then RAN node should send it out to the X application. X application approves it, and because of that approval, UE can hand over here and there. So this is how MHX application is working. All right, let's move on. Next one is the hardware integration, ORAN integration. So far, well, as of 1.4, basically we only supported OAI 4G RAN stack. So this is how it's working. There are three types of servers or cloud running, and one of the server, OAI NUC server, has OAI CU and DU device, CU and DU software RAN stack, and they can communicate with USRP v2.10 board. And by using that cell, we can connect the LTE to this cell. So this is RAN part. And also we need a core part, right? So as the core UPF thing is working within the Ether Edge Cloud, whereas as the core 4G's control plane is running in Ether control is Ether Central Cloud. We can use at GCP or AWS or Azure. So like MME or HS, all of those things are working in the central cloud, and UPF is running in the edge cloud. Well, of course, we can move that control plane into the edge cloud so that this edge cloud has everything. But well, this is the kind of the reference design. So 4G CU and CU are connected to as the core control plane and user plane here. And also we added the E2 agent for each OAI component. So this E2 agent can communicate with rig side here. And this rig, I mean the ONOS rig has KPI-X application and RSMX application. So this means that this rig can monitor how many UEs are connected or something like that. And also we can manage the RAN slicing as well. It is the 4G case. And by using UPF, well, of course, this UE can reach out to the internet. So that is 4G case. And now for 1.5 release, basically we integrated OAI RAN stack, 5G RAN stack with our own E2 agent. So it's, well, to be honest, it's not, OAI stack is not up to date. I mean, that is not the latest version. We forked old version and then added the E2 agent in it and then tested it. So the core side and I mean the cloud side, central cloud and edge cloud, they are the same. But NUC side, well, we just uses OAI, the standalone RAN stack for 5G, and we added our own E2 agent in it. And by using V2.10, we can communicate with the old 5G UE. I mean, normally we are using dongle, so we can use it. Well, dongle can communicate with this 5G network. And in the edge cloud side, well, it has a UPF. Central cloud side, it has a control plane. And of course, like I mentioned, this can be deployed in the edge cloud, but it is a reference design, so I just deployed it. And our rig side, basically, in 4G case, basically we could use not only KPI mode but also RSM service model, RSMX application. But now for 5G, as of now, we only support KPI-X application. So that is the USRP the OAI 5G RAN stack with USRP integration. And third bullet was our CI pipeline changes, right? Previously, as of 1.4, we have used the Jenkins CI. So the step is quite simple. If we create a PR or we merge the PR in our repository, then Jenkins CI has the webhook system. So once we create a PR or merge a PR, then Jenkins CI can capture that event. And once it's captured, then Jenkins starts provisioning the virtual machine on AWS and then run the CI pipeline, like build process, test process, publish process, etc. But from 1.5, now we completely replaced that Jenkins CI with the GitHub action. So it is very free and fast for open source. So, well, in Jenkins job, well, it took a really long time because it includes the VM provisioning process as well. But GitHub Action, well, is much faster than that process. So we integrated our own CI pipeline into the GitHub Action. And the scope is the same: build, test, publish, everything. Well, it's running over GitHub Action, and it's working fine, and it is already integrated. So if you create a PR or if you merge PR to, for example, add to create a new images, etc., then GitHub Action can take care of that. And the last one is Ether OnAmp for SD-RAN. And here I would like to introduce our new engineering team. They prepared the demo video for Ether OnAmp, how we can deploy SD-RAN with Ether OnAmp. So I will play this video.
Hello everyone, this is Hyun-Min Yu from SD-RAN engineering team and Mobile Communication Lab at Kyung University. In this video, I will show you how to install SD-RAN platform using ISO-LAMP tool. By following this guide, you can install SD-RAN on your own machines. Now, let's get started with SD-RAN installation process. Before we dive into the installation guide, I'd like to take a moment to introduce our SD-RAN engineering team. Our team leader is Dr. Ojun Kim, who is currently with Pure Storage USA. Our team members include Hyun-Min Yu, Kyung Kim, Seongjin Lee, Ho-Sung Choi, and Hyuk-Sung Kwon. We are all part of Mobile Communication Lab at Kyung University, Korea, and our supervisor is Professor In-gi Hong. We are managing the release process, designing SD-RAN software, and conducting research leveraging SD-RAN. Now let's talk about ISO-LAMP. It plays a crucial role in simplifying SD-RAN deployment. You can think of ISO-LAMP as a lifecycle management tool that simplifies the deployment of ISO platforms on your machine. It makes the SD-RAN deployment process easier. A key advantage is fast deployment. Users can easily set up a Kubernetes cluster and deploy SD-RAN with minimal effort. Instead of manual setup, LAMP automates most of the process. With ISO-LAMP, users can test their own 5G platform. It is a great tool for ORAN research and development. Now let's start our installation process. You can also find these contents on these sites. Before we start, let's see the prerequisite for our system setup. First, you can use Ubuntu Server 20.4, not the desktop version. And in your server, you need to set up sudo command to run without password. Next, you need to disable your firewall. You can check this by running sudo ufw status. If you see status inactive, that means the firewall is off. Finally, you should utilize systemd networkd instead of network manager. To check if systemd networkd is running, you can use the systemctl command. If you see active running, it means systemd networkd is managing the network properly and the setup is complete. Next, let's set up Ansible, an open-source automation tool for system setup and configuration management. It is a key requirement for ISO-LAMP. To install Ansible, we need to run the following commands. And after we install, we can check the version of Ansible. If you see the output similar to this one, Ansible is successfully installed and ready to use. Now let's download ISO-LAMP by cloning its repository. Then you can move into ISO-LAMP folder. Inside the folder, you can see various items, and you should note the host.ini file and vars directory. We are going to modify the host.ini file and vars directory for our installation. Inside the vars directory, we will find YAML files for SD-RAN setup. First, we are going to update the host.ini file. You can start by checking your IP address using the IPA command. In this example, you can see your machine's IP address. And please make sure to remember your IP. Next, open the host.ini file and enter your IP address. We'll also need to add your Ubuntu username and password. After that, you can complete the host.ini file setup. Now let's set up the YAML files. We are not going to run the main SDN YAML files directly. Instead, we'll copy its contents into main YAML file and use this file for execution. So please run the following cp command. After that, move back to exec folder. Now run make exrp earn to check the setup. If there are no errors or prerequisites are complete, we are ready to move on. Unlike the long prerequisite process, the installation itself is really simple. It is the biggest advantage of exec. All you need to do is run just 2 make comments in your exec folder. I prepare a short demo video. First, you can install the Kubernetes and then SERAM. So when you run the first make command, you can see the logs for Kubernetes installation. To verify the Kubernetes is up and running, you can use the kubectl command. Then you can see the pods running in the kubesystem namespace. As you can see, by running these 2 make commands, you can deploy SERAM very easily. The second command will deploy SERAM proper on your machine. On my machine, Kubernetes took about 4 minutes to install, and SERAM took another 4 minutes. So in less than 10 minutes, you can have your own SERAM system. Uninstalling SERAM is also very easy. You simply replace the word install with uninstall in the make command. If you want to uninstall Kubernetes as well, you can run this optional command. That's the end of our SERAM installation guide with exec. With just a few steps, you can set up SERAM in under 10 minutes. We also introduced how to uninstall SERAM and Kubernetes if you need. I hope this guide helps you get started with SERAM. If you have any questions, feel free to reach out to our team. Thanks for watching and enjoy working with SERAM.
Okay, thank you very much. So this is the kind of Ether on-ramp demo. So yeah, so let's briefly, I would like to add one more. So basically, the reason why we would like to deprecate SDRAN and would like to move everything into the Ether on-ramp is because like Humi mentioned, Ether on-ramp has more benefit than SDRAN in a box. And more beneficial thing is basically SDRAN in a box is working only for the development purposes, only for development purposes. Like if developer wants to add new use cases or test something, then SDRAN is a good option, but it's not. It's very limited for the production or staging or production. But because it's the SDRAN in a box is it can only create a cluster with a single host machine. But normally, if let's assume that we would like to create our cluster, normally we have multiple host machines there, and SDRAN in a box doesn't support multiple hosts. But Ethernet can support it because it's deploying the Kubernetes by using the kubespray with Ansible playbook, which means that this kubespray can cover the multi-host cases. So that is another beneficial. And also that is why we would like to move everything from the SDRAN in a box to Ethernet. So that is what I would like to add one more. Okay, there's some kind of minor updates. So like I mentioned, Python-based SDK deprecated, Python-based X application deprecated, and also user documentation is also updating. Well, some part is up to date, but some part is not up to date. So we, especially for hardware installation part. So we almost completed. So we will post the new user documentation for the USRP things. So please stay tuned there. So that is all the SDRAN 1.5 update. So like we can feel that SDRAN 1.5, the major point was we changed it X application with to work with the RC service model. We changed our CI pipeline. We introduced the OAI 5G RAN stack within SD-RAN project, and we are trying to change our deployment automation tool from the SD-RAN in a box to Ethernet. So those 4 bullets are the major point for the 1.5 release. And 1.6, well, there are a lot of work items like already. So well, here's the story. Basically, as you know, well, SD-RAN project stopped for a long time, like 1 or 2 years, and while we didn't work for SD-RAN, basically all other ORAN projects continued, and because of that situation, basically SD-RAN and other ORAN project has a lot of gaps. So after this 1.5 release, basically 1.5 release is just summarizing all the efforts that we made right after 1.4 release, and we released it to announce we did it right after 1.4. And 1.6, 1.7, those 2 releases, we would like to focus on reducing that gap between SD-RAN project and other projects. So first, well, SD-RAN is now currently using very old Go version and some multiple versions, and because of that, there are some security issues there. We would like to fix it. And as I mentioned earlier, OAI RAN stack is something we forked the old one, but we would like to change that part into the new one, the latest one and official one. And also we would like to consider SRS RAN things into the SD-RAN. And also it was demonstrated already, but we would like to integrate the non-real-time Greek officially. And also, if possible, if we have more time, then we would like to propose and POC some new use cases, and we would like to change some RAN simulator. Because RAN simulator, currently the RAN simulator is working standalone mode, but we would like to split that into the multiple in a microservice manner, and then we want to make it more efficient, work more efficiently and effectively. So the timeline is quite simple. So SD-RAN 1.6 will happen. The date is not decided yet, but probably sometime in Q3 or Q4. And we have a contact. So SD-RAN. We have a Slack channel, SD-RAN Dev. Currently, it's not working actively, but please post a message. I will try to respond as soon as I can. And also, or just email me or email to engineering team. We can handle it. So that is all I have today. Thank you for joining, and thanks for your time. If you have any questions, please post your question to the chat. Thank you very
I
much.
do see one question for you. Do you see it in chat?
Yeah, so I'm reading. So about the system requirement. Yeah, I think Hyunmin already answered. So SD-RAN installation. Well, at least 4 CPU cores and 16 GB RAM is required for Ethernet. But if you would like to deploy them in more smooth, I mean, our recommendation was basically at least 6 or 8 cores and 32 GB RAM and more than 100 GB disk. That should be necessary. Hope it can answer your question. And any other questions?
Okay. Well, thank you so much, everyone, for joining us, and thank you to our 2 speakers today.